Hello, and welcome back to the Intro to Python course here on Ladybug. And today we're going to talk about functions and a bit of debugging. Okay, so functions, what are they? Programmers love shortcuts that make writing code easier. One of the most common shortcuts is to give a name to a section or a block of code that does a pretty fundamental job in your program. Instead of having to type and retype out like the entire block of code each time you need it, you can simply type the name. So these named blocks of code are what we call functions. So how to use one. Using a function is also known as calling them. I know I've used this term a couple of times in this course, and that's what that means. It's to call a function. And to call a function, you just type the function's name followed by a set of brackets that contain any parameters you want the function to work with. Parameters are a bit like variables that belong to the function, and they allow you to pass information between different parts of your program. So a function doesn't need any parameters. The brackets are usually just left empty. So I know we've talked about a few built-in functions that Python has inside like the language that we can use in our code. So a common one that we've already discussed before would be print function. You know that one, where we put a string inside and Python will print it for us. We also know the input function. We've looked at that before as well. Input and print are kind of like opposite functions. The input function lets the user give instructions or data to the program. The print function sends output, so they're kind of like the input and output. We also have a few other functions that Python has built into it, such as the max function. So this function selects the maximum value from the parameters you give it. And remember, parameters are a bit like variables that belong to functions. So for example, if we would like to find the max of the numbers 5, 8, 4, 2, and 19, Bot can do that for us. We just put them inside our max function within the parentheses, and Python will output 19 because that is the biggest. And these numbers have to be separated by commas. We also have the opposite of that, which would be the min function, minimum. And this is the opposite of max. It selects the minimum value. So if we were to type the same exact numbers from the top, it would give us the smallest, which is 2. So we also have another way of calling functions. So some of the different types of data that we've come across so far, such as integers, strings, and lists, have their own functions. And these functions must be called in a special way. We usually type the data or the name of the variable holding the data, followed by dot, the function's name, which would be the function's name. And finally, the brackets. So we have another function that we have would be the upper function. So we type, for example, any string, let's go happy, dot, upper. Empty brackets mean that no parameters are needed. It would type whatever's in the string and in uppercase or in capital letters. So in this case, we put happy inside the string and it typed happy in capital letters. We can do this with other words as well. Remember, I'm putting my data first and then putting a dot and upper. Another function that follows this way of calling would be replace. So for this function, 2 parameters are needed. The first being a part of a string that we want to replace, and the second is a string that you want to put in its place instead. So the function returns this new string with the replacements made. So for example, if we want message to be just go I love swimming, and we want message dot replace. We want to replace it with, let's say, and we want to place some swimming. Just remember, watch my comma placement. I'm putting the comma after swimming, after the one I want to replace, and we're going to replace this with reading. Instead of I love swimming, it types I love reading. There's also the reverse function. So, and this function basically types everything inside a set of lists, everything within a list, backwards. So let's have a list, and we can call this one numbers. So numbers, type a set of numbers in here. We'll do 5, 4, 3, 2, 1. Now, if I want to print these numbers in reverse, which would be 1, 2, 3, 4, 5, I can type numbers dot reverse, and then my parentheses would be empty because I have no parameters for this function. I can then type print numbers in Python. We put 1, 2, 3, 4, 5. The best functions have a clear purpose and a good name that explains what they do, so we won't forget later on. It's important to define our functions before we use them in our main code to make our code concise and easier for us to go through it, for us and other people to go through it. So first step in making a function, we have to define it first. So I'm going to demonstrate this with an example. And I'm going to create a function that calculates the number of seconds in a day and then prints the answer on the screen. That is my goal here. So we are going to create a new file in the IZLE, save it as whatever we want to. I'm going to save this as seconds. And then first thing we're going to type is DEF, and this is short for define. This is really important because we always want to define our functions before we use them in our main code. And it's really helpful that we put our defined functions at the top of our file after any import statements. And by doing this, we won't make the mistake of trying to call a function before we've defined it. So defining functions should always be the first thing we do. And let's call this function print seconds. I put SECS for short, per day. I'm putting a colon after, so Python is going to automatically indent it. Hours are equal to 24. Minutes is hours multiplied by 60. I'm going to use my mathematical operators for multiply. We know that seconds are minutes multiplied by 60. And we want a function to print seconds. Then we want our program to print the entire function. And we have no parameters within our function, so we're going to leave the parentheses blank. I'm going to save this file. I'm going to run it and see what happens. And it printed the number that we wanted to. This is the amount of seconds in a day. 86,400 seconds. So if we would want to add parameters into our function, if we want to give our function any values to work with, we have to put them inside the brackets as parameters. So for example, to find out the total number of seconds in maybe a particular number of days, we can change our code to look like this. So we can put days here. Maybe instead of hours, we can do days multiplied by 24. Minutes would still be hours multiplied by 60. Seconds would still be minutes multiplied by 60. And we can still print seconds. But in our bottom line here, our last line, when we say print seconds per day, we can give the value 7 to the parameter days. So now when we run our function, or now when we run our program, I'm going to save it first. Right. Now when we run it, it will give us the number of seconds in 7 days. So as you can see, it's 604,800. Another thing we can do with functions is return a value. So now, once we have a function that does something useful, like our function, we would want to use the results from that function in the rest of our code. So we can get the values out of a function by returning them. So let's change our code to get the return value from our function. We should also rename the function to match its new purpose. So instead of print, we can define our function as convert days to seconds, because that's what we want our function to do now. And instead of our last line here, we say print seconds and then print our function. Instead, we can say return seconds. So we have define, and then we change our function name into convert days to seconds. Inside that, we have parameter days. We have hours equals days multiplied by 24, minutes equals hours multiplied by 60, seconds equals minutes multiplied by 60, and then we have return seconds, and that's inside the indentation. So the keyword return gives the value of the variable seconds, and the line that called the function is deleted, as the function now has a new name and purpose. So instead of running our code, don't try to run the code just yet, because then we have to store and use the return value. So we can store this value from a function in a variable to use later in our code. So we can add this small snippet of code after, and this would store the return value and use it to calculate the number of milliseconds. So we're going to name a variable total seconds, and this would be equal to our convert days to seconds 7, which would be in 7 days. Instead of days, we're going to put 7. We're going to name another variable called milli, which is short for milliseconds, and then we're going to make this equal to total seconds multiplied by 1,000, because that is what a millisecond is. It is a thousandth of a second. And then we want to print milliseconds. So we say print milli. I'm going to save this file, run it, and let's see what happens. There we have it. Instead of printing the number of seconds in 7 days, we printed the number of milliseconds in 7 days. So in step 3, when we returned value, we changed the name of our function from print seconds per day to convert days to seconds. So just like with variables, it's important that the name we accurately use explains what the function does. And this makes our code a lot easier to understand. So the rules for naming functions are similar to those for variables, and I know we talked about that in the second video. Function names can contain letters, numbers, and underscores, but they should always begin with the letter. And if there's several words in the name, those words should be separated by underscores, since we can't use spaces in a function. So before we move on to debugging, let's do a quick debrief of what we learned about functions. So there are a number of special words that coders use when talking about functions, and it's important to know what they mean. Call, I mentioned this before in this video and videos prior to this one. Call is used means to use a function. Define is when we use the def keyword and write the code for a function. Coders say you define the function. We also define a variable when we first set its value, so these two have similar meanings. A parameter is a piece of data or information that we use to give a function to use. They are placed in the parentheses of a function, within the parentheses. And a return value is data that we pass from a function back to the main code, and we can get it using the keyword return, like we did in the third step, or how to create a function. Okay, so welcome to the second part of this lesson, which would be fixing bugs. So if something's wrong with your code, Python will try to help by showing an error message. These messages can seem a bit puzzling at first, but they'll give you clues about why your program isn't working and how to fix it. So both the IDLE editor and the shell window can show error messages if mistakes are detected. An error message can tell you what type of error has occurred and where to look in your code. A pop-up box will usually appear to warn you that there's an error. You can click OK to return to your program. There will be a red highlight on or near the editor. And Python usually displays error messages in red text in the shell window. The program stops working when an error message appears. The message can tell you which line of code caused the error to happen. So here is the first kind of error message that we're going to talk about, which is type error. A type error isn't a typing error, which is, I know it sounds like that, but it actually means your code has mixed up one type of data with another, such as confusing numbers with strings. It's like trying to bake a cake in your refrigerator. It won't work because the refrigerator isn't meant for baking. If you ask Python to do something impossible, don't be surprised if it won't cooperate. Examples of type errors would be when you multiply with strings, you compare two completely different types of data, or tell Python to find a number in a list of letters. Those things aren't meant to be done in Python, and which is why Python will give you a type error. At the bottom, here's an example of a type error. In this example, it says can't convert integer object to string implicitly, and it gives you the line number 32. So you can go back and fix your error. Next, we have name errors. So the name error message appears if your code uses the name of a variable or function that hasn't yet been created. To avoid this, we should always define your variables and functions before you write code to use them. It's good practice to define all of your functions at the top of your program. So for example, a name error in this code stops Python from displaying the message, I live in Calgary. You need to create the variable place first before you use the print function. So the print instruction in this case needs to come after the variable instead of before. You should first define a variable and then say print. We have syntax errors. So when you have a syntax error message, it's a hint that you've typed something incorrectly. Maybe your finger slipped and hit a wrong letter, but not to worry. These are the easiest errors to fix. We should always check through our code carefully and try to spot what went wrong. So examples of type errors. Are you missing a bracket or a quotation mark? Do your pairs of brackets and quotation marks match? Maybe you made a spelling mistake. All of these things can cause syntax errors. So it's important to look through our code so we can pinpoint what exactly went wrong. An example of a syntax error would be here when we put input, what is your name? We forgot to put the second bracket after our string, which can cause an invalid syntax error. After that, we have indentation errors. Python uses indentation to understand where blocks of code start and stop. An indentation error means something is wrong with the way we structure a code. And we should always remember that if a line ends with a colon, the next line must be indented. Python usually does this automatically for us, which we should always double check and make sure our code is properly indented. And to manually indent a line, we press the spacebar 4 times. In our program, we usually have one block of code within another block, such as a loop that sits inside a function. Every line in a particular block must be indented by the same amount. So in this case, we wrote if we get equals true, print close, but our print function isn't indented properly. So Python will give us an indentation error, expected an indented block. And last but not least, we have logic error messages. So sometimes we can tell something in our program has gone wrong, even if Python hasn't given us an error message, because our program isn't doing what we expected it to. This is probably because we have a logic error. So maybe we typed the code incorrectly, but if we missed an important line or put instructions in the wrong order, even if the actual code is correct, it still won't run properly. Logic errors can be tricky to find, but as we get more experience, we'll get good at tracking them down. Try to identify logic errors by checking your code slowly, line by line. It does take a long time, but in the end, we will find our problem. And examples of logic errors would be, there's a lot of logic error in it. The value of the lives is shown on the screen before the number of lives is reduced by 1. The player of this game will see the wrong number of lives remaining. So we should always make sure that our print lives, we have to move it to the end after the variable lives equals lives minus 1. So, what exactly should we look for debugging our code? Sometimes you might think that you will never get a program to work, but if you feel that way, don't give up. If we follow these tips properly, we will be able to identify most errors. We always want to ask ourselves, is everything spelled correctly? Do you have unnecessary spaces at the start of a line? Have you confused any numbers or letters, such as 0 and O? Have you used any uppercase and lowercase letters in the right places? Also ask yourself if all open parentheses have a matching closing parenthesis. Do all single and double quotes have a matching closing quote? And then maybe ask someone else to check your code. And have you saved your code since you last made changes? Thank you so much for watching through this lesson and taking the time to listen. Next, we have our final project, and that will be it. So hopefully you're excited for that. And thank you.